Hello and welcome. This video is a workshop based on the Food for Fork case study and the decision tree cheat sheet posted in the course materials folder. It is designed to assist you in selecting and performing an appropriate statistical test when examining a hypothesis, which may be a helpful resource when completing the data analysis assignment. I suggest before proceeding with this recording, you familiarise yourself with the case study which I have posted in the assessments folder. The Food for Fork case study asked you to conduct 5 hypothesis tests based upon survey data and prepare a report that details your analysis and recommendations for a prospective restaurateur, Michael. The 5 hypotheses are: does the average income of the people surveyed differ from $68,500? Is there a difference in preference for simple decor and elegant decor? Is there a difference in the mean amount spent in restaurants each month across people with different marital statuses? Is there a difference in average price people are willing to pay for an evening meal across postcodes? And can the average amount people spend on food each month be explained by the average price people are willing to pay for entrees, age, gender, family size, and income? So let's begin by addressing hypothesis 1. Does the average income of the people surveyed differ from $68,500? We begin by determining the null and alternative hypothesis. Our null hypothesis for this test would be the average income of people surveyed is equal to $68,500, and our alternative hypothesis would be the average income of people surveyed is not equal to $68,500, which is a two-tailed test. The next thing we need to ascertain is which statistical test we should be using. To do this, I'm going to use the decision tree or cheat sheet. In line with the decision tree, we begin by determining if we are testing for difference or testing for association. Because we are testing whether income differs from $68,500, we conclude that we are testing for difference. Next, we have to determine whether the data is continuous or categorical. The data we are using is income, which is continuous. That is, a variable that can take on a range of values that correspond to some quantitative amount. Finally, we need to determine how many variables we are using. In this test, we are only using one variable, income, so the appropriate test is the univariate t-test. Now that we have determined which test we should use, we perform the univariate t-test in Excel. So let's jump over into Excel. To perform the univariate t-test, we need to copy the income variable into a new workbook. So we copy our variable and paste. Next, we need to add another column that has our $68,500, and we fill that column down. We then will select data analysis, and we're going to select a t-test PAD 2 sample for means. We use this test because there is no univariate t-test in Excel, but the PAD 2 sample for means performs exactly the same calculation when entered in this manner. So if we select OK, our variable 1 is our income. Our variable 2 range is our set amount of $68,500. Our hypothesized mean difference is nothing. Our alpha is 5%, or our level of significance, and we will select the output range. We then click OK, and we come up with our univariate t-test result. Okay, the results of this test indicate that the mean income is $72,087.50, and this income is significantly different from $68,500, given a t-stat of 2.48, which is greater than the 1.97, the critical t statistic, and a p-value of 0.013, which is less than 5%. That is our level of significance. As such, we can reject the null hypothesis that the average income of people surveyed is 68,500 and accept the alternative hypothesis that the average income of people surveyed is not equal to 68,500. Our next hypothesis is hypothesis 2. Is there a difference in preference for simple decor and elegant decor? Our null hypothesis for this test would be preference for simple decor is equal to the preference for elegant decor, and our alternative hypothesis would be preference for simple decor is not equal to the preference for elegant decor. To determine which statistical test we need to apply to examine these hypotheses, we will go back to our decision tree. We note again that we are testing for difference, that is there a difference in the preference for simple decor and elegant decor? Further, we are using continuous data, as preference for simple decor and preference for elegant decor are ranges of values that correspond to some quantitative amount. Finally, we are using two groups, and the samples are paired. That is, the responses are from participants in the same sample, which means we should perform a paired samples t-test. So to perform the paired samples t-test, we need to jump back into Excel. We need to select simple decor and elegant decor and copy and paste them into a new workbook. We then need to select data, data analysis, and the t-test paired to sample for means. We select our first variable and our second variable. Our hypothesized mean difference is 0, alpha at 5%. Select our output range and click OK. The results of this test indicate that the mean preference for simple decor is 2.75 out of 3, and for elegant decor is 2.0325 out of 3. These preferences are significantly different given a t-statistic of 20.11, which is greater than the critical t-statistic of 1.97, and the p-value is 0. You can see this a bit better if we format our numbers, and we can see there it's 0. Now that is less than 5%, which is our level of significance. We can therefore reject the null hypothesis that the preference for simple and elegant decor is the same and accept the alternative hypothesis that the preferences are different. So moving on to hypothesis 3. Is there a difference in the mean amount spent in restaurants each month across people with different marital statuses? Our null hypothesis for this test would be the mean amount spent in restaurants each month by single people is equal to the mean amount spent in restaurants each month by married people, which is equal to the mean amount spent in restaurants each month by other people. And our alternative hypothesis would be there is at least one difference. We now need to go to our decision tree, and we can choose the appropriate statistical test to examine these hypotheses. Again, we are testing for difference, that is, the difference in the mean amount spent by different marital status groups. Our data is again continuous because it is based on the amount spent, and we are using 3 groups: single, married, and other. So an ANOVA test is the most appropriate test. To conduct the ANOVA test, jump back into Excel, and we selected the variable marital and total spent per month, and we copy them into a new workbook. We then need to separate the three groups in our marital variable. So we select data and sort the data, or we select the sample, and then we are going to go data sort by the marital variable. We then need to split our sample, so we split it where our 1 becomes 2, so single becomes married. Cut and paste. And then where our married becomes other, so our 2 becomes 3. We want cut, not copy. And paste. So if we just copy these headings across, and if we identify this as variable 1, this one as variable 2, and this as variable 3, we can then delete these extra columns, and we have our variables for our ANOVA. We then are going to select data analysis. This time we are using an ANOVA single factor, as we only have one grouping variable, which is marital status. Click OK. We select our range, which is the whole sample, making sure that we get every data point. We are going to group by columns, or we have grouped by columns. Our labels are in the first row, and our alpha is 5%. So we need to select our output range and then click OK. Okay. So the results of this test indicate the mean amount spent in restaurants by a single person is $227.32. The mean amount spent in restaurants by a married person is $220.20, and the mean amount spent in restaurants by an other person is $218.56. These preferences are not significantly different, given an F value of 1.51, which is less than the critical F value of 3.02, and the p-value of 0.22, which is greater than 5%. That is our level of significance. We cannot therefore reject the null hypothesis that the mean amount spent in restaurants each month by single people, married people, and other people are different. Hypothesis 4 asks us, is there a difference in average price people are willing to pay for an evening meal across postcodes? Our null hypothesis for this test would be there is no difference in the average price people are willing to pay for an evening meal across postcodes, and our alternative hypothesis would be there is at least one difference. We now go to our decision tree to choose the appropriate statistical test to examine these hypotheses. Again, we are testing for difference. That is the difference in the mean amount spent by different postcode groups. Our data is continuous, which is amount spent, and we are using 4 groups, postcodes A, B, C, and D. So an ANOVA test is the most appropriate test. To conduct the ANOVA, jump back into Excel and select the variable postcode, evening meal price, and copy them and paste them into our workbook. We then need to sort the data based on the postcode. So if we select all the data and sort postcode, OK, and then we need to split our data. So where postcode 1 becomes postcode 2, we cut and paste. Where postcode 2 becomes postcode 3, again, cut and paste. And where postcode 3 becomes postcode 4, cut and paste. We then copy these headings across, and we're going to change this so it's postcode 1, postcode 2, postcode 3 and postcode 4. We can then delete these extra columns. And now we have our data available for our ANOVA. We then are going to go data analysis. We want ANOVA single factor again because we only have one grouping variable, which is the postcode. We select our data, remembering to get all the data right down to the bottom. We are grouping by columns again. We have labels in the first row and our alpha is 5%. If we select our output range and then click OK. Let's make these columns a bit wider so we can see. The results of this test indicate that the mean amount spent in restaurants by people living in postcode A is $24.77. The mean amount spent in restaurants by people living in postcode B is $23.27. The mean amount spent in restaurants by people living in postcode C is $23.45, and the mean amount spent in restaurants by people living in postcode D is $24.69. These preferences are not significantly different, given an F value of 0.71, which is less than the critical F value of 2.63, and the P value of 0.55, which is greater than 5%, that is, our level of significance. We cannot therefore reject the null hypothesis that there is no difference in the average price people are willing to pay for an evening meal across postcodes. Our last hypothesis test is number 5. Can the average amount people spend on food each month be explained by the average price people are willing to pay for entrees, age, gender, family size, and income? Our null hypothesis for this test would be the average amount people spend on food each month is not explained by the average price people are willing to pay for entrees, age, gender, family size, and income. And our alternative hypothesis would be the average amount people spend on food each month is explained by the average price people are willing to pay for entrees, age, gender, family size, and income. We now go to our decision tree to determine which statistical test to use. This time we are testing for association. That is, can the amount people spend on food be explained by certain factors? Our data is continuous, amount spent on food, and we are using 5 variables, so we need to perform a multiple regression. To perform the multiple regression, we jump back into Excel. Now we need to select the total spent per month. We need to select average price. We need to select age, so year born, gender, family size, and income. So if we copy all of those variables across to a new workbook. Now our variables are all fine apart from the gender variable, which we need to recode from male equals 1 and female equals 2 to male equals 0 and female equals 1. We do this using an if function. So we will write equals if this cell is equal to 1, then we are going to code that 0. Then we're going to say if that cell is equal to 2, we're going to code it 1 for a female, otherwise return us a blank cell. We then can fill that formula down and now we have recoded our gender variable. If we copy and then paste special that using only values and number formats and then hit enter, we can actually delete this out and we just have our recoded variable with ones and zeros. So we can now perform our regression or our multiple regression. So if we go data analysis, this time we want a regression, select OK. Our Y input range is the total spent per month. And our X input range is all of these variables here. And I'll just make that variable include the heading. So we have labels. Our confidence level is 95%. If we select an output range and click OK. So here's our regression results. So the results of this test indicate that the independent variables explain a significant proportion of the variation in the dependent variable. This is denoted by the F value of 8.75 and the associated p-value of 0, which again I'll just format those cells into numbers so you can see that a bit better. The test also indicates that the average price is not an explanatory variable with a t-statistic of 0.12 and a p-value of 0.91. It also indicates that age or year born is an explanatory variable with a t-statistic of 5.35 and a p-value of 0. Family size is also statistically significant and therefore is an explanatory variable with a t-stat of 2.59 and a p-value of 0.01. Gender is not an explanatory variable with a t-stat of 1.28 and a p-value of 0.2. And the income variable is an explanatory variable with a t-stat of 2.99 and a p-value of 0. So I hope you have found the information contained in this recording helpful, and I thank you for watching. Good luck with your data analysis report.